The flea might seem like a minor nuisance, barely noticeable until it bites. But these tiny creatures have a story that's far more fascinating and scientifically rich than most realize. Fleas have roamed the earth for millions of years, surviving across ages, plagues, and epochs by adapting their biology and behavior to thrive in a variety of ecosystems. They're masters of survival and efficiency, showing us how complex life can be even at its smallest and most seemingly inconspicuous scales. The mighty flea, a minuscule marvel, though often overlooked. Fleas are among the most successful parasites in the animal kingdom. These minute insects, barely a few millimeters long, are perfectly engineered for a life of parasitism, with the ability to leap 200 times their body length, a resilient exoskeleton, and a life cycle finely tuned to environmental conditions. Fleas are more than just bloodsuckers. They are evolutionarily honed survivors. In this detailed exploration, we'll dive deep into the anatomy, life cycle, history, and environmental role of fleas, along with their complex interactions with hosts, including humans. This will give us a fresh perspective on fleas as not just pests, but as tiny wonders of biology. The anatomy of a flea, a microscopic machine. The anatomy of fleas is a masterpiece of evolution. Despite their small size, every part of their body is designed to maximize their ability to survive and reproduce. Here's an in-depth look at the key aspects of their structure: exoskeleton and physical adaptations. The flea's exoskeleton is a tough, resilient shell that not only offers protection but also aids in its parasitic lifestyle. Made from a rigid polymer called chitin, the exoskeleton allows fleas to withstand pressures far beyond their size. Their flattened bodies make it easier to move through the dense fur or feathers of their hosts, while their hardened shell helps them avoid being crushed by scratching or biting. The power of their legs. Fleas are famous for their jumping ability. A flea's hind legs contain muscles with an elastic protein known as resilin, which acts like a spring when the flea is ready to leap. This protein allows it to release an explosive amount of stored energy. The force produced in this process can propel the flea over distances 200 times its body length, equivalent to a human jumping over a football field. The structure of their legs, equipped with sharp spines for grip, further aids in landing securely on a host after a leap. Feeding apparatus, the perfect parasite. The flea's mouthparts are perfectly designed for piercing skin and feeding on blood. It consists of sharp, needle-like structures known as stylets, which are used to penetrate the skin of the host. Fleas inject their saliva, containing anticoagulants, into the wound to prevent the blood from clotting while they feed. This is crucial to their survival, allowing them to feed undisturbed for extended periods. Their feeding habits are particularly effective because of their capacity to consume blood far greater than their body weight in one feeding session. A flea can ingest blood amounts up to 15 times its body weight in a single feeding, which it needs to fuel its highly active metabolism. Flea behavior and adaptation. Survival of the fittest. Evolutionary success of fleas. Fleas have been evolving for over 100 million years. Fossil records show that even during the time of dinosaurs, flea-like insects existed, parasitizing early mammals and birds. This long evolutionary history has honed their ability to adapt to new hosts and survive under a wide range of conditions. Jumping as an adaptation for survival. One of the flea's most remarkable adaptations is its ability to jump. Not only does this enable them to hop between hosts, but it's also an effective defense mechanism. Fleas use their jumping ability to evade predators and escape from the grasp of irritated hosts. The energy-efficient mechanism of their jumping is akin to a biological catapult, where their specialized musculature and exoskeleton work together to create tremendous force in a short burst. This is a key reason why fleas are notoriously difficult to catch or kill by physical means. Host detection. Fleas possess an acute ability to detect potential hosts from a distance. Their sensory organs can pick up changes in heat and movement, as well as chemical cues, such as carbon dioxide, emitted by warm-blooded animals. Once they land on a host, they use their well-adapted claws to cling onto hair or feathers, burrowing deeper into fur or plumage to remain hidden. Blood feasting and parasite strategy. Fleas are hematophagous, meaning they feed exclusively on blood. Unlike many parasites that only feed sporadically, fleas are constant feeders. Their sharp stylets pierce the host's skin, allowing them to feed while injecting their saliva, which contains anticoagulants to ensure smooth blood flow. This can cause intense itching in the host, leading to discomfort and even allergic reactions. The flea life cycle, a complex dance. The flea's life cycle is intricately linked to environmental conditions and the availability of hosts. Fleas undergo complete metamorphosis, progressing through 4 distinct stages: egg, larva, pupa, and adult. Egg stage. The female flea lays eggs after a blood meal, and she can lay up to 50 eggs per day. Flea eggs are smooth and pearl-like, typically laid on the host but often fall off into the environment. These eggs can survive in the host's bedding, carpets, or outdoors in shady areas, waiting for the right conditions to hatch. Larval stage. The flea larva hatches from the egg within 1 to 12 days, depending on environmental factors like temperature and humidity. The larva is a small, worm-like creature that feeds on organic matter, primarily flea dirt, the dried blood excreted by adult fleas. The larval stage lasts 5 to 18 days, during which the flea avoids light and burrows into dark areas where it can continue feeding. Pupal stage. Once fully grown, the larva spins a silk cocoon. Entering the pupal stage, the flea may remain in the pupal stage for a few days or several months, depending on environmental cues such as warmth, humidity, and the presence of hosts. This stage is highly resilient, and fleas can remain dormant in their cocoons, waiting for favorable conditions before emerging as adults. Adult stage. Once the adult flea emerges, its primary goal is to find a host and feed. Without a blood meal, adult fleas can only survive a few days to weeks, depending on environmental conditions. Once on a host, however, adult fleas can live for several months, feeding and reproducing. Fleas and disease, tiny vectors of big problems. Fleas as vectors of disease. Fleas are infamous for their role in spreading some of the deadliest diseases in human history. The most notorious of these is the bubonic plague, caused by the bacterium Yersinia pestis. Fleas that fed on infected rats spread the bacterium to humans during the Middle Ages, leading to the Black Death, which killed millions across Europe and Asia. Fleas are also vectors for other diseases, such as murine typhus, a bacterial disease transmitted from rats to humans, and cat flea rickettsiosis, which affects both cats and humans. Fleas and allergic reactions. In addition to diseases, fleas can cause severe allergic reactions in some hosts. Flea bites can trigger allergic dermatitis, which leads to intense itching, swelling, and discomfort in some animals, particularly dogs and cats. Flea allergy dermatitis can cause hair loss, skin infections, and even secondary bacterial infections due to excessive scratching. Fleas and ecology. Their role in the natural world. Though fleas are primarily known as pests, they do play roles in natural ecosystems. Fleas as part of the food chain. In the wild, fleas are part of the natural food chain. Flea larvae feed on organic debris and help break down dead matter, contributing to nutrient recycling in their environment. Additionally, fleas are prey for a variety of insect predators, including ants and beetles. Their larvae are also consumed by other small invertebrates, while adult fleas occasionally fall victim to spiders or birds. Parasitic relationships in the animal kingdom. Fleas have a wide range of host species, including mammals and birds. While these parasitic relationships can be detrimental to the host, they are an essential part of flea survival. In natural settings, such as in the wild, the interaction between fleas and their hosts maintains a balance where the fleas feed without causing too much harm, while the host may benefit from the immune challenges posed by the parasite. Historical impact of fleas, disease, and civilization. Fleas have had a profound impact on human history. Perhaps the most significant instance of this is their role in the transmission of the bubonic plague during the 14th century. The Black Death and flea transmission. The Black Death, one of the deadliest pandemics in human history, killed an estimated 75 to 200 million people across Europe and Asia in the 1300s. The flea was a critical vector in this pandemic. Fleas infected with Yersinia pestis would bite humans after feeding on infected rats, transferring the bacterium to their new host.